Alrighty, good morning everybody and welcome to the wolfSSL live webinar on all things FIPS 140-2 with wolfSSL engineers Kaleb Hines and John Safranek. My name is Kajal Subkoda and I will be moderating this webinar. All attendees will be in listen-only mode. If you have any questions, please feel free to use the Q&A box or raise your hand to be unmuted if you would like to ask the question live, as we do host a Q&A session following the presentation. The webinar will also be recorded and made available on our YouTube channel shortly after the presentation. And I invite everyone to follow us on Twitter at wolfSSL, as well as all of our other socials. And please feel free to email us at facts@wolfssl.com if you have any additional questions. And now I'd like to give a brief company overview before we move on to the technical presentation. So wolfSSL was founded in 2004 by Todd Auska and Larry Stefanik when they realized there wasn't an open source, dual licensed embedded SSL library available. OpenSSL existed at the time, but there was a demand for an alternative that was easily portable, smaller, faster, available under a clear commercial license, was equipped with a clean and modern API, and offered commercial-style developer support. wolfSSL was born into this market need with an OpenSSL compatibility layer. Today, wolfSSL secures over 2 billion connections. We have more than 1,000 OEM customers and dozens of resellers. wolfSSL is made up of almost 40 dedicated employees in 2020, most of which are engineers. This process, of course, is supported by a strong partner network that we're very proud of, which includes ISRG, STMicro, and Curl, for example. Since the beginning, our engineering team has developed several embedded security products, including wolfCrypt with DO178 support, FIPS certification, and a FIPS-ready offering, MQTT up to the version 5 specification, SSH version 2, TPM 2.0, a secure bootloader known as wolfboot, as well as Java wrappers and JSSC support and commercial style support for curl. All of these offerings are, of course, accompanied by a thorough maintenance and support plans up to the 24/7 level. We also offer full service consulting. And now I'm going to hand it over to Kaleb for the presentation.
Okay, thank you, Kajal. So today we're going to be covering the topic of FIPS 140-3, and we'll try to touch on some of the more common questions that we get through our support channel regarding FIPS and operating environments and some of the various terminology associated with FIPS. So just kind of a general overview of the 140-3 spec and what we can expect moving into the future and how it will affect the 140-2 certifications that Wolf has been doing previously. So first we're going to cover the timeline. So as of September 22nd in 2019, almost a year and a half ago now, the 140-3 spec became effective, meaning vendors like wolfSSL could start preparing for when testing with 140-3 went live. And we got access to some of the early RFC drafts and things like that. wolfSSL started preparing for the transition from 140-2 to 140-3 in January of 2020. And we started that effort by beginning development of an in-house proprietary ACVP test harness that would allow us to meet the needs, all the testing requirements for the 140-3 specification. including adding new algorithms to the harness, etc. Testing for 140-3 began on September 22nd of last year. wolfSSL was about 90% complete with our ACVP harness by that point, and we received our first ACVP algorithm certificates on the CERT 3389 in December of 2020. Our developer, John Safranek, who is also with me today, is currently working on our 140-3 CERT and is using that same test harness to meet all the needs he has for testing with 140-3. On September 22nd of this fall in 2021, 140-2 submissions will cease, and the CMVP will no longer accept 140-2 submissions, only 140-3 after September of this year. And then any modules that are approved under the 140-3 spec this year will be moved to the historical list and sunset as of September 21st, 2026. And after that point, only 140-3 will be effective. So 140-3 is the new standard for federal government. Federal Information Processing Standard is what is defined as FIPS. And this is a standard for all cryptographic modules that are consumed and used by the federal government. wolfSSL is proud to be one of the first in the market to be on the in-process list with the CMVP. Some of the benefits that our customers can enjoy with the new 140-3 spec are that the standard has been modernized. So 140-3 is more in line with some of the international standards, ISO and IEC, for example. And so 140-3, we foresee it being more widely adopted throughout the world as a whole and less US government and Canadian government specific. So it should expand the market or the potential market for your FIPS validated operating environments. It will be easier to stay up to date. So our engineers have spent a lot of time adding continuous integration testing to ensure that any modules that were certified will always work in current and future releases. And the new 140-3 specification has stricter requirements and standards, which in turn provides more assurances to your end customers that their cryptographic modules are being run through a stricter set of tests in order to achieve compliance. With 140-3, we have the advent of hybrid modules. So when the 140-2 spec was written back in the day, it was written assuming that only hardware would ever be running the crypto. As I'm sure many of you are all aware, there are software modules now, and finally NIST and the federal government are allowing a lot more adaptation for the software modules, which is nice. And what that means is that with a combination of software and hardware, is we can now achieve validations that are higher than level 1. Under the 140-2 spec, software modules could only be certified under level 1. Now, with hybrid modules, we can combine software and hardware to achieve level 2, level 3 certifications. And finally, conditional algorithm self-testing. So previously, under the 140-2 specification, all algorithms supported by a module had to be tested at boot time or during the power-up cycle, which on some embedded devices could actually be quite time-consuming. So for example, if you had RSA 4096-bit or 3072-bit supported in your module, you had to run a 3072-bit or 4096-bit test during the power cycle. On smaller embedded devices, this could often take upwards of a minute or more, so boot times were problematic. But now with the new 140-3 spec, you only have to test the algorithm when you go to use it. So if you're only using AES GCM, for example, you only have to run an AES GCM self-test, and you never have to worry about RSA being tested. So this enhances both boot times and for those customers only using a subset of the module, runtime efficiency. So we've mentioned NIST a few times. If anyone isn't aware of what that is, we wanted to give a little background. So NIST is the National Institute of Standards and Technology. It was a government body set up to kind of stipulate and drive the policies that affected use of cryptography by the government. They implement practical cybersecurity and privacy standards, and then they enforce the application of those standards and best practices on the vendors and consumers of the cryptography. And the overarching goal of all of that was to facilitate adoption of best practices in cybersecurity capabilities. The CMVP is another government body that you'll often hear talked about with FIPS. And the CMVP is a government body established by NIST and the CSEC. And for those who aren't aware, the CSEC is the Canadian government equivalent to the US government's NIST. And the CMVP is in charge of promoting the use of validated cryptographic modules by government entities, securing those the security metrics that are used by those entities, and the CMVP establishes the certifications for CST laboratories, which are FIPS certified labs, the only ones who are allowed to do the operational testing for these modules. The CST labs verify that the module has met the cryptographic and security requirements, and each lab has to submit the evidence to the CMVP to ultimately be issued a certificate for an operating environment. This is a general overview slide of the validation process. I don't know if you guys can see my mouse, but item 1 here is us, the vendor, wolfCrypt. We submit for testing to a lab who then coordinates with us during the testing phase of the process. And then our lab submits all the evidence of the testing to the CMVP, who then reviews and ensures that we met all the requirements during the testing phase. And then if there are any issues, they'll kick it back down to the lab, who kicks it back down to us. We'll fix it, resubmit. And once everything is good to go, then the CMVP issues the validated certificate or updates the existing certificate with the newly validated operating environment. This is just kind of a general architectural overview of what we send to our customers. So here in the center, we have the SSL and TLS library, which is outside the validation scope of FIPS. And then we have the wolfCrypt FIPS module, which is what gets validated. So when we send releases to our customers, let's say we did a validation for you in January of 2019, we often get the question, well, you just sent me a new release, how can I use it? Because we validated back in January of 2019, can I use this new release? And the answer is yes. So when we ship releases, we update the SSL and TLS code and everything outside the FIPS module boundary, and then we rip out whatever is currently being used in our development master branch and replace that with the FIPS crypto module. So you will always receive the crypto that was validated in January of 2019, and you'll receive the latest and greatest SSL and TLS code. wolfCrypt is being used today to secure billions of endpoint connections throughout the world. And we're pretty proud of that, so we just called that out. Moving on to the next slide, these are some of the updates you'll experience with the wolfSSL FIPS 140-3 certificate. as compared to our 140-2 certs. So in the new cert, as we mentioned before, it's a merging of the FIPS and ISO standards to make it more international and potentially open up your markets, more foreign markets, to those customers of ours that are using our FIPS module. The CAST, formerly the CAVP, which is now the ACVP, has streamlined all the testing, and we're only testing the algorithms that are being used. So that helps weed out some of the unnecessary algorithms. In our new cert, we've added support for the TLS version 1.3 and TLS version 1.2 KDFs, key derivation functions, for those of you who don't know what a KDF is. And that's now covered in the FIPS crypto boundary. And we've also added support for the SSH KDF to help support our wolfSSL client and server products. We've also extended testing to include 4096-bit RSA under 140-2, and the CAVP testing, we could only do up to 3072-bit. Now with ACVP, we can do 4096-bit. We've also added testing for ECDSA with the SHA-3 algorithm. Previously, you could only test for SHA-1 and SHA-2. And we've removed testing of insecure algorithms, and the example is triple DES. We removed triple DES. And as I've been going through, I've been saying operating environment a lot, and we do get a lot of questions. What is an operating environment? So we wanted to define that for those in attendance today. An operating environment consists of 3 items and 3 items only. It is the chipset, and the example here that we chose was the Intel Core TM i7-7820. This is one of the chipsets validated in our certificate today. The operating system that we validated that chipset on was Windows 10 Enterprise Edition. And the cryptographic module that was used in that validation was wolfCrypt version 4.2.0. And those are the only 3 things that comprise an operating environment. We often get asked, does the compiler matter? And the answer is no. What matters is the binary object that's running in the operating environment. When you might hear this term, OE, or operating environment, is when you're speaking with potential FIPS customers. So it's good to be aware of what it is and the definition. And you'll often hear it if you're speaking with our support staff or any of our FIPS engineers. Deciding which OE is right for you is also a question we get fairly often. And to be frank, we can't answer it. So a lot of it's driven by the market and the customers. Let's say maybe you have a software product you're offering today, and that software product can be deployed on any number of laptops or desktops or server blades, and you aren't sure which one to validate. Well, keep in mind that the OE is described as a chipset, an operating system, and a crypto module. It doesn't say it's running on a desktop or a laptop or a server. So maybe you can identify a common chipset amongst all your customers, or a common operating system amongst all your customers. And maybe you'll target that one first. Maybe you validate that operating environment first. And then if you have another subset of your customers using a different operating system or a different chipset, you can easily go back and add more operating environments later. And once you have the first one on the certificate, it's easier to add future ones that are very similar. Also, for those embedded users, we just wanted to call out that thanks to our in-house proprietary ACVP agent harness, wolfSSL is one of the only legitimate vendors that is doing validations on embedded IoT projects for software modules. So we've done validations in embedded RTOSs like OpenRTOS, FreeRTOS, ThreadX, etc. Some of the steps to adding an operating environment that we're often asked are covered in this slide, and I'll try not to read each of them verbatim for the sake of time, but we will get a copy of this slide deck to anyone who wants it, I believe, after the webinar, so you can go back and read these all in detail if you want, but we'll go over these briefly. The entire process to add an operating environment to an existing certificate takes about 2.5 to 3 months. To do a brand new certificate typically takes us between 9 months and a year, but the most common cases that we see are users wanting to add their operating environment to our existing certificate. So keep in mind that's just a 2.5 to 3 month process. The first phase typically takes us 2 to 3 weeks to achieve, and that's where you, the customer, sends us, wolfSSL, the vendor, all the hardware, software, and accessories, think cords, USB serial cables, etc., that we need so that one of our engineers can sit down, build Flash, if applicable Flash, and run a Hello World program on the target. Once we have the Hello World program running, we then port the SSL and crypto layers to the target. And not all customers are using the SSL layers. We only port that when it's needed, but we always port the crypto module, obviously. And then we, in great detail, document each of the changes that is made during the porting process. So for example, if we were porting to a ThreadX environment, we might have to set up the mutexes and the threading conventions for that operating system. And so we'll detail each of those changes, and then that's all submitted to our lab, and we keep a copy on file. In the case of an audit scenario, we have copies that we can send to customers. Once the porting is complete and the crypto is running like we expect it to, we then port our agent harness onto the device. And then we run a set of vectors that we already know the answers to on the target as a sanity check, letting us know we're ready to test with the lab. Once our sanity checks are complete, we'll fill out the vector request paperwork and submit that to the lab to kick off the testing process. The lab will then send us a set of demo vectors first. If those pass, then they'll send us a set of production vectors, and if those pass, then we're ready to get algorithm certificates issued. And while we're waiting on the algo certs, we port a operational testing application in place of the harness in prep for phase 2. In phase 2, once the algo certs are issued, we can then schedule a date for operational testing and code review with our lab. Thankfully for software modules, it's possible right now to do remote testing, so we don't have to actually fly down to our lab like we used to back in the day. But part of that is we have to abide by all the specifications in the IG note G.17. Oops, sorry about that. G.17. And we have to fill out a bunch of paperwork that meets each of the requirements in the G.17 directive. We write a guide for our lab tester that gets assigned, and then they follow our guide when doing the op testing remotely. And part of that requirement is a secure VPN connection to ensure that no testing results are modified in transit between our site and the lab during the testing process. Once all that is complete, we sign a bunch of forms that say we abided by all the rules, we did everything correctly. We provide those signed documents to the lab, and they place them in an evidence folder, which is ultimately submitted to the CMVP. We then update the security policy with the algorithm certificate numbers that were issued in phase 1, and our lab now has everything to submit. Once we get notification they've submitted to CMVP, we have February, which is kind of a wait period where we're just waiting on the CMVP to say everything was done correctly and issue the certification. And part of the time in phase 3 is a negotiation process on the ambiguity of an operating environment's listing. And just to be absolutely clear, this isn't to hide anything. So I put a note down here at the bottom of our slide. The intent is not to hide anything about the operating environment when we're being ambiguous. The intent is we want to be ambiguous enough that the customer, let's say a backdoor was discovered in Windows operating system 10, and they needed to accept a security update that closed the back door, but did not affect the way that the operating system managed the crypto and handed the crypto off to the chipset. We want them to be able to accept those kind of updates, and that way they aren't locked into a version that has a backdoor fixed in it. Solutions that can benefit from the FIPS module. Obviously, we talk a lot about our SSL and TLS library. And I briefly mentioned the SSH product, client and server, before. But some of our other products are the MQTT client, which is a pub sub client that uses the SSL and TLS library underneath. Our Wolf Boot, which is a secure firmware update solution and uses the cryptographic module only. And then some of our language wrappers, the most commonly used ones are our Java wrappers, our JSSE and JCE providers, and other language wrappers that we've had FIPS interest in are the Python and C# wrapper. Third-party solutions that can benefit from our FIPS module are Nginx, WPA Supplicant, Strong Swan, OpenSSH, Apache, S-Tunnel, Lighty, and the largest third-party benefiter of all is OpenSSL. So if many are not aware, OpenSSL lost their FIPS accreditation. And so we've been filling that gap for a lot of our customers via the Engine API that OpenSSL offers. The OpenSSL Engine API allows users to plug in third-party cryptographic solutions, replacing the OpenSSL crypto. And so wolfCrypt FIPS fits in there nicely. And when you plug it in, system-wide, any applications that are using OpenSSL can now be using the FIPS-validated wolfCrypt module. And it just becomes a drop-in replacement. Lastly, we wanted to cover where we're at today in the FIPS 140-3 process. So as of right now, we're one of the first in the world on the in-process list, like we mentioned, using our proprietary ACVP test rig. We've completed all the algorithm testing. We've submitted everything to our lab. All the evidence is with the lab, and we expect to be out of the lab and into NIST in the next couple of months. We currently have a target date of September to be the first FIPS 140-3 cryptographic library certified. And obviously that depends on government schedules. Our in-house test rig, which we talked about a little bit, currently runs on Linux, Windows, and Mac OS, so we can certify those systems. And it also works on IoT edge devices, so we can certify those network edge point devices if you're looking to certify those. And if you ever have any questions and you need to come to us, you'll get assigned an engineer that's involved in the process. So anyone you talk to here at wolfSSL will be knowledgeable on the FIPS 140-3 spec and the process. And that kind of concludes the information we had to present today. So now we're going to enter our question and answer phase. Be sure to post your questions. And like I said, we'll try to get a copy of these slides to all the attendees after.
Alrighty. A question is, has Zypher OS with STM32 chips been targeted as an OE?
Not yet, but we'd love to do it.
Do updates to the operating system change the OE?
It depends. So remember, I briefly mentioned that part of the phase 3 of adding an operating environment is that ambiguity negotiation and how ambiguous an operating system can be listed. So let's say if we were doing OpenSSL, or sorry, if we were doing Windows 10 and we called out a specific build of Windows 10, and you wanted to move to a new build, that would affect the operating environment. But if we listed just Windows 10 and didn't call out the build number, you could update to a new build number. As long as it was still Windows 10, it would be good. So those, yeah, it kind of depends on what was called out in the OE on whether or not an update will affect or change the OE.
Awesome. Can we have details on the type of program and data memory wolfSSL library uses on certain well-known platforms like NXP, 32-bit, or ARM controllers?
Yeah, great question. So it depends on the math library, but a typical build size is between 80 kilobytes and 120 kilobytes. That's our typical build sizes. We can always optimize. It can fluctuate. There's some more optimal builds we can do, but they do involve security relevant changes. So we'd probably have to recertify if we wanted to get it smaller. And then as far as runtime resource usage, it would depend on if you're doing, say, an SSL TLS connection and you're using ECDHE RSA cipher suites, you can expect roughly in the ballpark of 21K of heap and 16K of RAM. If you're using ECC cipher suite only, that usage drops to about 16K of heap and 12K of RAM. Or sorry, I should say 12K of stack instead of RAM. And if you're using PSK, ECDHE, PSK cipher suites, I believe it's down in the ballpark of 10K of heap and 8K of stack. We could get more detailed numbers if we had a specific use case.
Okay, awesome. Are the tested configuration sections in the CMVP record defining all OEs?
No. So tested configuration is different than OE. For example, when we are listing the tested configuration, remember I had talked about, you might have an OE that runs on servers, desktops, and laptops. As long as the chipset operating system and wolfCrypt module used are all the same, it doesn't matter if it's a desktop, laptop, or a server. But in the tested configuration, we do actually have to call out what the product is that we were testing on. So we might call out your server blade machine in the tested configuration, but it doesn't affect the operating environment, if that helps.
Fantastic. So this question is, they've heard as of today, CMVP is moving at a glacial pace because of COVID. Is this what wolfSSL is also experiencing?
I wouldn't necessarily call it a glacial pace, but yes, we have experienced delays. So we used to see turnaround times from the CMVP of about 2 weeks. Like we would send everything to our lab would submit to the CMVP, and then the certificate would be updated in about 2 to 3 weeks. Now that's more like 4 or 5 weeks. So we've seen a doubling of the turnaround times with COVID-19, yes.
Awesome. Is the wolfCrypt or is wolfCrypt for OpenSSL license compatible with GPL environments like Fedora?
So wolfCrypt for OpenSSL license? I honestly don't believe I could answer that question. I think that would have to go up to our CEO and CTO for answering. But I will say wolfSSL offers 2 licenses. We do an open source license model, and you can use FIPS-ready under our open source. I believe it's GPLv3 for the FIPS-ready product. That one hasn't been validated though. It can be used in open source. And then we also offer commercial licensing. So I'm not quite sure how the licenses play with OpenSSL and Fedora. I think that would have to go to our legal department. I'm sorry.
Alrighty. Do you have any specific protection mechanisms for key material when in RAM?
Yeah, so we do a couple of different key material protections. One is timing resistance. We have timing resistance baked into 2 of our math libraries. And we also do a blinding mechanism to mask which RSA operations are being performed at any given time. So someone sniffing the cache wouldn't be able to tell when the private key was being loaded in, for example.
Fantastic. Are you currently in testing for COS, ECC, SSC, and COS, FFC, SSC? If so, will that be reflected in our next certification in this FIPS 140-3 process?
Great question. I'm fairly certain we are, but John, could you take that one? Are we doing key agreement scheme, ECC, SSC, and FFC, SSC?
Yes, we are.
Perfect.
So it will be reflected.
Okay, fantastic. Let's see. Are you likely to achieve an approved NDRBG? I don't know what that is.
Yeah, so we
okay.
we use a deterministic random bit generator that uses the hash algorithm SHA-256. John, are we doing anything other than that in the new cert?
No, but if your operating environment does have a yeah, and oh, these acronyms, there's so many. If it has the NDRBG, we can take advantage of it, and then your keygen will be, you know, we can at that point specify the security level of the keys that you're generating with it. We can't guarantee the security level, unfortunately, without that good NDDRBG. So I think currently we work with the K80 has one on board that we can take advantage of. On our old cert, we have support for that. Okay.
Okay, thanks, John.
Okay, which algorithms in wolfCrypt are certified with FIPS 140-3?
Oh gosh, I'd have to go pull up the certificate. What I can do, we can put a link in here to our old cert 3389, and just be aware, I believe the only algorithm we removed was DTLS, or sorry, not DTLS, DES3, correct, John?
Yeah, we removed DES3, and then we're adding KDFs for TLS 1.2, TLS 1.3, and SSH version 2. And then we are adding the KAS SSC for test for fixed field and elliptic curve, and we're adding ECDSA with SHA-3 support, and we're testing for some larger RSA keys. So.
Okay. And Codrell, where's that question in the list? I'm trying to spot it. So I can type a response.
It's the fourth one in the list. Do you see it?
Ah, got it. Okay. So I'm going to put a link in there to our existing certificate. That way you can go check out, and like John said, we've removed triple DES, but we're adding those additional things, and everything else that's currently in the 3389 cert will be in the new 140-3 cert.
Okay, fantastic. Is it required to modify third-party software such as Nginx or their makefiles to be able to use it with wolfSSL, or do they support wolfSSL out of the box?
Yeah, so Nginx, it is required to modify it, but what we do is we maintain a set of patches for specific versions of Nginx. So we send the customer a patch file. They simply patch their version of Nginx and then use a specific version of wolfCrypt FIPS with that version of Nginx.
Okay, fantastic. So whoa. Sorry, I'm just looking through some questions. Is the ECC for efficient key agreement over the curve 25519 included in wolfSSL FIPS 140-3?
No, it is not. And John, correct me if I'm wrong, but I don't believe that NIST offers testing for curve 25519, do they?
I don't think they have it yet. They're still working on it. I think they are going to be adding it at some point, but I don't think they have it
today. Yeah, that's also my understanding. I can get more clarification. Was that the one from Marcus Steele?
Yes.
Okay. Marcus, if you send an email, if you're still on the line, if you send an email to our support@wolfSSL.com with this question, we can dig into it a little more and get your response on that.
Alrighty, and Peter Wright has his hand raised, so I'm going to allow him to ask the question live.
Sure. There we go.
Oh, sorry about that. I didn't realize I was on mute over here. The only question I had was if there was plans on sending out a package of wolfCrypt separated from wolfSSL on GitHub like you do for wolfMQTT and all that sort of stuff.
That is a great question. And it's actually something we've discussed often in our team meetings. The answer is right now it's not on our roadmap, but it is a desire we have for the future. We would like to eventually separate wolfCrypt and wolfSSL into two separate libraries that could be distributed separately. But for the time being, we will continue to distribute wolfSSL with wolfCrypt packaged inside. And if there is a great need for that too, be sure to send an email to us about it. The more questions and requests we get for features like that, the higher it goes up in our to-do list, and will eventually get implemented.
Awesome. Is it required for an OE to run on top of an operating system to be certified, or is it okay to run on bare metal for the embedded MCU?
Unfortunately, the answer is yes, an OS is required. However, with that being said, we have done custom operating systems that were as very simple as simply a thread scheduler loop, or just a loop that's basically barely above firmware. In those cases, we do have to provide additional evidence and basically show how it can be classified as an operating system. But that is something we have done. In fact, we just did one recently like that. But it does require an OS in the listing. We can't, the CMVP will not validate bare metal.
Okay. Would it be possible to certify an NVIDIA Tegra platforms with Yocto based on operating system as an OE? And how much ambiguity is possible with the Yocto configuration while still maintaining compliance?
Sure. So with Yocto, we've done several Yocto builds now. And typically the CMVP has been fine just listing the version of the Linux kernel. So if you look at our cert today, you'll see Linux, I believe 4.19 was as ambiguous as we got with one of the Yocto builds. There's also Linux 4.12, Yocto standard running on Metasys SNC series network controller. And I take that back. So the Linux 4.19 is submitted to the CMVP right now. It hasn't been validated yet. So it's not in the cert, should be within the next week or two. So yeah, as far as the ambiguity, it's a matter of calling out the kernel version in Yocto. And then on the chipset, that's a little more interesting. We haven't ever done anything on, what was the chip again? I believe it was a video card, graphics card, wasn't it? Yeah, NVIDIA graphics card. So we've never done that, but I don't see why it wouldn't be possible.
Okay.
What do you think, John?
It's possible. I mean,
yeah.
Yes, we can.
Sure. Yeah, that's my leaning as well. Yeah, I don't see any reason why we couldn't.
Okay, awesome. Why does OE matter? Does it mean that the crypto algorithms implemented for Windows OS are also dependent on the processor? And what about virtual machines running on Windows OS?
Great question. So we haven't done any virtualized environments in CERT 3389 yet, but on CERT 2425, we did do 2 separate hypervisors, one running in ESXi and one running on Windows. So the only stipulation the CMVP has is that we call out both operating systems. So you have to call out which one is running in the hypervisor and which one is the host. And the OE, I do not know why NIST has issued the guidance surrounding the operating environments and why they determined that operating system, chipset, and crypto module were the requirements. That was something decided on by the government and NIST. We just abide by it.
Okay, fantastic. How does the FIPS 140-2 levels compare to the FIPS 140-3 levels, and what can we use wolfSSL for?
So in FIPS 140-2, a software module could only be level 1, which is basically a cryptographic module that does a power on self test and then checks itself for integrity. So we hash the entire module in memory, and then we verify that against a hash that was generated in the factory. And if the runtime hash does not match what was computed in the factory, the module won't boot. And every call into the module will return an error until it's restored to factory settings. Level 2, I don't know these all off the top of my head, but they basically escalate from that, something that does a power on self test and sanity check, up to level 4, which is basically self-destruction and tamper resistant, as well as physical access barriers. And I believe level 2 adds the physical access barrier. Level 3 adds the physical access barrier with zeroization of memory. And then level 4 adds self-destruct capabilities. So the chip would basically catch on fire and burn up, so nobody could ever recover it if someone tried to tamper with it. And then in FIPS 140-3, software modules can now combine with hardware modules to achieve higher levels of certification. So we could combine, let's say, wolfCrypt software that's making some of the algorithm calls out to a chipset, and that chipset has physical access barriers on it. So then we could combine wolfCrypt and that chipset to achieve level 2 certification.
Great. Can wolfCrypt and wolfSSL be used in a static memory environment as opposed to dynamic memory allocation for IoT environments?
Yes, it can. The only trick with static environments and building the library statically is that we have to supply a linker script to determine the order that the module goes into memory. And we have to always force the module to be isolated from the rest of the system, so that when the integrity check is computed over the module, we're not hashing parts of the the operating system or other parts of the application, etc. But yeah, that's something we've done fairly frequently in our certs.
I'd like to follow up on that with with wolfboot. We had to have modifications to wolfCrypt so that it did not allocate any memory. So doing the public key operations, when you're running on an embedded processor before the OS is going, you don't have much memory management available. So we did do that, and then many of our algorithms have been updated for. We have what was it, DOS testing on many algorithms. It's a standard for aviation, and that requires no memory allocations. For wolfSSL as a whole, no, we definitely take advantage of dynamic memory for a lot of things, but we have been slowly making it so that many of the crypto primitives don't need it.
Mm-hmm.
So there
we also have users can plug in their own custom allocators. So you could easily set it up to where you have, say, a pool of static memory, and then your own custom alloc functions that hand out chunks of that static pool whenever say a wolfSSL malloc operation is called. It's actually getting static memory from your pool instead of dynamic memory off the heap.
From a static pool, but yeah.
Yeah, sorry. Yep.
Okay, and we have a few more minutes left, so I'm just going to ask like 1 or 2 more questions, and the rest of the questions asked will be answered and sent via our follow-up email following the presentation with the recording linked to it as well. So is it possible to integrate wolfCrypt into Linux Yocto based on distribution instead of OpenSSL, but transparently / seamlessly to the OS and applications? So could they still keep using the OpenSSL interface?
Yes, and that's exactly what the engine API from OpenSSL is used for. So we write basically an interface between OpenSSL's engine API and our cryptographic library. And then the user is none the wiser. They don't know which crypto is being used underneath, and you can ship it that way. And then you can continue to use your OpenSSL APIs at the application level.
Awesome, fantastic. Okay, I just would like to thank everyone for attending this webinar. We had a lot of great questions, and thank you so much for participating and being proactive in it. As a reminder, this webinar is recorded and will be sent following this presentation in your emails, as well as a list of the remaining questions answered. And if you would like to access a PDF version of the presentation, please request us or email us, and we'll be happy to provide you with that as well. And again, I'd just like to thank everyone for attending this webinar. I invite you to follow us on Twitter at wolfSSL. And if you have any other questions, please feel free to email us at facts@wolfSSL.com. And thank you so much for the presentation, Kaleb and John. It was great.
Mm-hmm. Yeah, absolutely. Our pleasure.
Nice talking to everybody.
Mm-hmm.
Yeah.
It was great. We had so many great questions.
Yeah. All right. Signing off.